Welcome back to TriStar Observatory. This is Gordon, aka Eeyore Equus, and today we have part 2 of our observatory tour video. In part 1, we took a look at all the components that make up the imaging rig. Today, we're going to talk about the electronics, hardware, and software that run everything. Let's begin with the one thing all of this stuff needs: a dachshund. Wait, I don't think that's right. Oh, yes, power. The entire observatory is solar powered, which admittedly makes this image amusingly circular. Solar power is collected by a pair of 100-watt Renogy solar panels available for about $115 a piece. I routinely see over 180 watts on clear summer days and over 140 watts on clear winter days, so I'm very impressed with the performance of these panels. Power is routed from the panels through the wall and down to the storage and management system. Charging is provided by a Bogart Engineering SC2030 solar charge controller, which charges a pair of Crown CR235 6-volt batteries. Everything is routed through a marine bus bar, which distributes power throughout the observatory, and through a 100 amp 100 millivolt shunt, which provides voltage and current information for the management system. All equipment in the observatory is tied to a 30 amp marine circuit breaker, which both protects the equipment in the observatory and allows me to shut everything off at the source if necessary for maintenance or installations. Battery management and power monitoring are essential to any solar power system, and the Trimetric 2030 from Bogart Engineering excels in this role. Admittedly, the user interface is, well, frankly, it's straight out of a Heathkit box from the 1970s, although no, it doesn't flicker like this. That's just a trick of the display's refresh rate in the camera. However, the Trimetric gives you complete control of all aspects of your solar power system. It manages battery charging, monitors power both entering and leaving the system, provides historical information about power consumption, and when paired with the SC2030 charge controller from Bogart, will customize charging profiles to meet any set of conditions. Furthermore, Bogart Engineering is a superb company to deal with. The owner, Kadar, was extremely helpful to me in my quest to construct a serial device for capturing and logging power information for later display in my observatory status dashboard. They also have a well-deserved, outstanding reputation for service after the sale. I simply cannot say enough good things about Bogart Engineering or their products. To use all these free amps provided by our friend the sun, power is fed from the batteries up through the wall and onto a shelf in what passes for my control room. Power goes first through a D-Rock voltage regulator, which can take anywhere from 6 to 32 volts input and will output anywhere from 0.8 to 28 volts. The output is adjustable. Mine is set to deliver 12.6 volts to all the components in the observatory. The regulator provides input power for a West Mountain Radio Rig Runner 4005i. The 4005i is an internet-enabled power distribution panel that allows monitoring and control via a simple web interface. It also provides an XML feed of current power status, which provides the power usage data and device status for my OBS status dashboard. The Rig Runner provides 5 individually controllable fused output ports. Each also has a configurable soft fuse for custom power limits. On the first output port is the roof controller and motor. The motor is a salvaged windshield wiper motor operated by a Pololu simple motor controller and Arduino firmware controlled by my own ASCOM Dome driver. On the second port is the feed line for the main imaging rig, which is then split and distributed by the bus bar at the pier as I showed you in the previous rig tour video. Next is an output for the observatory computer, an old Lenovo laptop running on a SuperPower car laptop charger. Unfortunately, these are no longer available, so I'm not sure what I'll do for laptop power once this one dies. On the fourth port is the internal OBS cam, a WansView W2 IP camera. These are good little cameras. They seem to survive outdoor conditions quite well and are available for around $50. This camera provides a 24/7 view of the rig and allows me to monitor slews and other mount movements from my main PC in the house. And on the final port is the observatory's router, a simple Netgear Wi-Fi enabled router that accepts 12-volt DC input. It provides network connectivity for all of the network-enabled devices in the OBS and receives its network feed via a shielded Cat6 cable buried in conduit running from the main router in the house out to the OBS. So there you have it. Power collection and management, distribution to all the various devices that make up TriStar Observatory, and a couple of pictures of one of our resident dachshunds. In the third and final OBS Tour video, I'm going to take you through all of the software involved in setting up, configuring, and running an imaging session. Who knows, I might even do that one live, so stay tuned. Thanks for watching, everyone. Go out and have a great day.